Welcome everyone. This is going to be the third year presenting Stargazing with the Ancients, or will it? Today I'm actually going to talk about Australians. Just for a little background, 2 years ago I spent 6 months in Sydney, Australia doing some student teaching for English language arts. And while I was there I took the time to do a little research into the native astronomy. So I'm here to talk a little bit about that today. First, let's go over some of the basics. Why am I talking about astronomy in a different part of the world? Isn't it basically all the same thing? Well, yes, in that the sky is always the sky. However, we're only looking at a fairly small slice of the sky at any given position on the Earth. Because Earth and the universe are three-dimensional objects, fortunately, sorry 12th century Europe, features such as trees, hills, and the rest of our planet will block our vision from time to time. And for this reason, we can only see from a fairly narrow perspective from our location here in North America, whereas Australia has an entirely different vantage point. So in order to understand this a little better, we're going to have to go over a couple of terms. Declination is essentially latitude, projected onto the celestial sphere. That's measured just like latitude in degrees north and south of the celestial equator. Therefore, points north of the celestial equator, this line here, have positive declinations, while those to the south, down here, have negative declinations. Right ascension is the celestial equivalent of longitude. Both right ascension and longitude are measured, or rather, measure an east-west angle from a 0 point on the equator. For longitude, that is the prime meridian. For latitude, that is called the first point of Aries, which is a fancy term for where the sun crosses a line on the vernal equinox in March. Now, just to give you a little more information about how you can see farther in various directions depending on where you are. We are currently at about 41.5 degrees north latitude. That means that we see a certain slice of the sky from where we are. Assuming we're on a perfectly flat plane, we can see 90 degrees to either direction. That means we can see to a maximum of negative 48.5 degrees declination. The celestial equator is 0, north celestial pole is 90, and that gives us a 180 degree slice of sky. That unfortunately is not true here, considering we have trees, hills, and other features blocking our path. Also, this only applies if we're looking due south. To look east or west of due south would give us a much shorter perspective. We wouldn't be able to see as far as 48.5 degrees declination. Now, there are 88 constellations recognized by worldwide astronomers. From our current location in New Milford at 41 degrees, 34 minutes, 37 seconds north and 73, 24, 30 west, we can view 50 constellations in their entirety. We can view parts of 14 more depending on what time of year it is and the time of day. However, there are 24 more constellations completely unaccounted for. Those constellations are found to the south, beyond our 48.5 degrees south declination. Because observers on the other side of the equator have an entirely different declination than northern observers, they are treated to a very different night sky. While there is some overlap, objects with more extreme declinations are fairly exclusive. What you see here is a stylized chart of the south circumpolar constellations, and what that means is constellations that are exclusive to the southern skies. They essentially orbit the southern celestial pole. A few famous examples are Crux, or the Southern Cross. That's probably the most famous of the southern constellations. There's also Reticulum, Hydrus, Octans, Chameleon, Pictor, Puppis, and a variety of others. Now, while the Southern Cross is the most famous in the Northern Hemisphere, it is hardly the only show in town. Along with the Southern Cross, the Southern Hemisphere is distinguished by an entire suite of constellations, unfamiliar to most Northerners, unless you are a famous astronomer or you've traveled a lot. The major constellations in the south include Hydrus, the sea serpent, Carina, the ship's keel, Puppis, the ship's stern, Pyxis, the ship's compass, Vela, the ship's sails, and Reticulum, the net. Now, those of you who are fairly observant will probably have noticed that there is a pattern to these constellations. They're all nautical terms. That's because the majority of these constellations were named during the Age of Exploration after Columbus discovered North America in 1492. Nautical nomenclature was something of a fad at the time. Now there is, like I said, some overlap. Orion actually is extremely visible in the Australian summer as opposed to slightly visible during our winter. Now there are a few very important stars in the southern hemisphere, just like there are in our northern hemisphere. We have Polaris. Unfortunately, they can't see it, being in the south. So instead, ancient navigators would use the star Canopus, or Alpha Carinae, in the constellation Carina, as their sky mark. It's the second brightest star in our sky after Sirius. Before the advent of magnetic compasses, Canopus was used as the marker star. It's the brightest star within 700 light years, with an apparent magnitude of 0.72, negative 0.72. Another important star, much angrier looking, is Eta Carinae, also in the Carina constellation. It's a much dimmer, you can just barely make it out with the naked eye. It has an apparent magnitude of 6.21, it's about 7,500 light years away from here. It's an extremely variable, luminous blue star. The star is given to eruptions that exceed 1 million times as bright as our star. That's extremely bright, just for a bit of reference there. One such supernova imposter event, that's what they call these flare-ups that the star is prone to, observed in 1843, so it happened 7,500 years before that, made Eta Carinae the second brightest star in our sky. And these eruptions produced the Homunculus Nebula, which is the kind of nuclear blast-looking thing you see there. Now, this one's actually kind of scary to me. VY Canis Majoris is remarkable just because of its size. It's the largest known star anywhere in the universe. It's a high luminosity M-class red hypergiant, and that essentially means that it's 1,800 to 2,100 times the radius of our sun. So to put that in perspective, it would swallow the orbit of Saturn. Now, can I ask one of our regular members, where is Saturn being placed in New Milford with the solar system model? Anyone?
We're making a solar system model. The sun will be right out here.
6-foot sphere.
6-foot diameter sun. All the inner planets will be on the high school campus out to Mars. Jupiter will be located at Hill and Plains School. Saturn will be out over in Perrybrook Park. And then Uranus at Cernoble. Neptune will be in front of the library. And we're also going to include Pluto.
That's very sweet of us.
Not as a planet, but as, you know, people might not like it if we don't have Pluto. So that'll be at Canterbury School.